Hello all, welcome to my YouTube channel. So in today video we are going to discuss about cryptography. So basically a cryptography is a technique which is used to secure your information or encrypt your information with the help of three techniques. So one is called hashing, another one is symmetric key, and another third one we have asymmetric key. So let's understand in more detail. So what is cryptography? Cryptography is a technique of securing information and communication through use of codes so that only those persons for whom the information is intended can understand it and process it. So what does it mean basically? Suppose you have a sender and a receiver. You want to send some information from one person to another person. Then the particular information which will be sent with the help of cryptography techniques, those information or that particular data can only be understood by a sender or receiver because they are intended to understand or process it. So the prefix crypt means hidden and suffix graphy means writing. So basically in simple words it's a hidden writing. In a simple word, if I say what does mean cryptography is a hidden writing. So none of the middle person can understand or see your information. In cryptography, the techniques which are used to protect information are obtained from mathematical concepts and set of rules based calculation known as algorithms to convert messages in a ways that make it hard to decode. So basically, cryptography used many algorithms to encrypt your data, and it's likely impossible to decode it if you don't have any particular key which is required to decode that particular file, text or message. Then you can't do that. It is not very straightforward. It is very hard. These algorithms are used for cryptographic key generation, digital signing, verification to protect data privacy, web browsing or internet, and to protect confidential transactions such as credit card and debit card transactions. So basically these cryptographies algorithms are used by these many service providers or what is consumers. So like for if somebody is using web browsing, if they are browsing any websites, then that particular person can use. If you are making any transaction from credit and debit card, then those banking guys use those techniques to secure the transaction. So that is basically cryptography. So basically we are hiding information from the third party who is not authorized to view or see that particular or modify that particular information. So that's the purpose of cryptography. Features of cryptography. So there are four features of cryptography. First one is confidentiality. Confidentiality ensures that only the intended recipient can decrypt the message and read its contents. So whoever is authorized or who is a valid user can only view or read the message which is transferred to that particular person. Next we have integrity. Integrity focus on the ability to be certain that the information contained within the message cannot be modified while in storage or transit. So basically whenever we send information from client to server, those information during the transaction period, that information should not be modified by any of the anonymous user or anonymous person. So those things basically it will take care by that integrity. Next we have non-repudiation. So non-repudiation means the sender of the message cannot backtrack in the future and deny their reason for sending or creating the message. And next we have authentication. So authenticity ensures that the sender and the recipient can verify each other's identity and the destination of the message. So authentication, some kind of certificate or keys we use to authenticate. So these are the basically four features of cryptography. Now we will see hash functions. Generally we call it hashing. So hashing refers to the process of generating a fixed size output from an input of variable size using the mathematical formulas known as hash function. So like basically you will provide one input value, like input string you have provided, suppose hello world, then that hello word will be encrypted with the help of hash function, and it will convert it to the some kind of hash value. Basically we will see in coming slides. So there is no uses of any keys in this algorithm. If you are using hash function hashing, then there is not requirement you have to use any private or public key to encrypt or decrypt that particular message. Hash function are hash function are irreversible. So it's basically a one-way function which protect the data at the cost of not being able to recover the original message. So you should have to use hash function only if you want, like you don't want to recover or decode that particular message. Then only you have to use hash function. The only way to crack a hash is by trying every input possible until you get the exact same hash. So if you have to decrypt that particular input value, then what you have to do, you have to try multiple times until you will not get the same value, same input value. So some of the most famous hashing algorithms are MD5, SHA1, SHA2, SHA3 and while pool. So these are the algorithms basically which is used in hashing. We will see in a demo. The result of hashing algorithm called a digest and also called checksum, fingerprint, hash and etc. So whenever you provide any input value to be encrypted, then the final output will be called as a digest and also called as checksum, fingerprint, hash and etc. So there are many names for that particular output value. So if you can see in this particular image, hash algorithm example. So I have ABCD till Z. So basically we know there are 26 characters. So suppose I have passed the string hello as an input value, and this passed through this particular hashing algorithm, and the digest value come 52. Now we will see how basically this value is calculated 52. So if you see in this particular ABCD format, the H comes in a 8 number. So 1, 2, 3, 4, 5, 6, 7, 8. So this is the first letter is H, then we have 8 plus 5E is a 5 number character. So we have especially 5. Similarly, L comes in 12 place. So 12 plus 12 plus O comes in a 15 place. So if you add if you add all these values, then it will become the digest 52. So this will be the output, hash output of this particular input string which you have provided. If original data is changed, then the digest will be different. So suppose instead of hello, you have typed cello. So now C comes on a third letter. So here basically a 3 instead of 8, we have now 3. So now 3 plus 5 plus 12 plus 12 plus 15, it becomes 47. So what basically I am trying to say here. So if you modify a single character also of any input variable, in that case the digest value will be changed. So similarly, so generally in real world we don't use this simple standard algorithm because it is not very secure and it's not very scalable, because we can see the digest value is 52. If people want to decrypt this value like from 52 to hello string input value, then they can try multiple attempts from this particular ABCD table. So they can easily crack it. Okay, the 52 digest value comes with hello. Similarly for this particular input value. So it's not very secure, and generally we don't use in real world. So real world hashing algorithm must satisfy 4 requirements. Impossible to extract the original message. Slight changes produce drastic difference. The resulting digest is fixed with length. Infeasible to produce a given digest. So if I'll see all these 4 points with this particular example, then it's not like if you see the impossible to extract the original message. Here we have a digest value is 52. If somebody is trying to decode this particular digest value, then like after maybe an hour or two, they can easily crack it. So this point is not valid for this particular hash algorithm. Similarly, for slide change produce a drastic difference. So here I have what I have done. I have changed H to C. Now the digest values become 47. So again, it's very easy to crack it. So if you have to use hash algorithm, you have to basically satisfy all these 4 points. Then it is secure to use hash algorithm. We will see more detail in next example. So if you see here, these are the PowerShell script file. These are all the same files basically. But what I'm doing here, if you see the file name here, we have hello.txt, and the content inside this file I have simple hello, and here I have used MD5 as a algorithm, hash algorithm. I have used MD5. So when I'm taking this hash value of this particular string, where we have hello, so you can see the content inside the file, we have hello, and the length of this hash we have 32. And again, if I'll go back to my previous slide, so there is a 1 point, the resulting digest is fixed with fixed length, so the length should not be changed. So if I'll go again to my next slide, so if you see in all the 3 examples, here is a word is hello, here is a word text we have in the file is hello, and here we have some large string like this is hash demo. So again, this value is 32. So it means this particular example is satisfying this particular line, resulting digest is fixed with, because in all the places we have 32, 32 and 32. Let me show you in real time. So suppose this is my PowerShell file, and I also open the hello.txt file. So now you can see I have only simple word hello here. Now let me run this particular command. So you can see the hello is the input variable, and the length of this particular, the digest value for this particular is this one, 5D41. So the length of this particular digest value is 32. So if I'm changing, okay, let me open the file again. So if I'm changing this particular text here, instead of hello, I'm putting this is just a demo for hash. Now I'll save it. So if you can see, now we have a large string value here, large content inside this particular file. So now if I'll clear the console here and I'll run it again, now again you can see the length, digest value length is still the same, 32, because we have used MD5. If instead of MD5, if I'll use any other so if I am using SHA1, now let me run it. So now you can see the digest value is 40. So based on the algorithm, you can use this hash function. So I hope my point is clear to you. So now next we have encryption. So encryption is used to provide the confidentiality. What does confidentiality? Only intended recipient can interpret the data. So whoever is authorized or whoever has the key to decrypt the particular message, they can only read or see or view the content of this particular file or particular message. So if you see here, the hello is a plain text, and we have specified to encryption so basically the input variable plain text is before data before encryption is called in a plain text format. After encryption, it's called a cipher text format. So if you can see here, the hello word after encryption is become LOHEL. So this is called a simple encryption. So transform plain text into ciphertext is called a simple encryption. What the problem with simple encryption? If you have to send same data to multiple user, then you have to use different algorithm to or different ways to encrypt the data. Otherwise, it is very easy to crack it. And if I'm using simple encryption, then I have to use standard algorithm, and the entire public knows how to decrypt it, so it's not secure. So what does it mean basically? Suppose this hello text I have to send to 4 users, and I'm using the standard encryption method, which is generally known by all the public, basically how to decrypt it. So they can easily decrypt within hours or 2 or 3 hours. They can easily able to encrypt our data. So it's not very good to use simple encryption method. That's why we used key-based encryption. So there are two types of key-based encryption. First, we call a symmetric cryptography or encryption. So secret key cryptography is also called a symmetric cryptography. So you should not be confused, because there are two terms: secret key cryptography and also we call a symmetric cryptography. Both are the same things basically, but different name. So because the secret key cryptography is also called a symmetric cryptography, because the same key is used to both encrypt and decrypt the data. The single key needed to encrypt and decrypt messages in a shared secret between the communicating parties. So what does it mean basically? If you see in this particular image, I have only one single secret key. So this particular secret key I am using for the encryption, and the same encryption key I am using for the decryption. So this particular secret key should be shared with both sender and receiver, but not through this particular channel. It should be through some other external media, or some like any other media. You can share this particular secret key. So it becomes the security gap, because if you are sharing this particular secret key to third party who want to decrypt this particular data, then maybe it can be what is called maybe it can be stolen, or it can be somehow basically a third person can get this particular secret key. Then they will easily able to decrypt your message, your data. So it's not so basically it's not much secure. So it's basically generally used for if you have bulk data, then you can use this symmetric cryptography. So there are a few algorithms which is used by the symmetric encryption algorithm. So firstly we have DS, which use basically 56-bit key encryption. Then we have RC4, then we have 3DS, then we have AES. So these are the algorithms which is used by the symmetric or secret key encryption. Next we have asymmetric cryptography, or we also called a public key cryptography. So here basically what happened, we use two keys to encrypt data. One is used for encryption, while the other key can decrypt the message. So one key is kept private and is called the private key, while the other is shared publicly and can be used by anyone. Hence it is known as the public key. So if you see in this particular image, we have two keys here, two public key basically. So one is a public key and another one we have a private key. So public key basically we are using to encrypt our data, and private key we are using decrypt the data. So this particular private key we can share with publicly, because the name says we can share it, but we cannot share the private key, because this key basically will use or to decrypt our data. So the mathematical relation of the key is such that the private key cannot be derived from the public key. What does mean? So if you don't have public key, you can recreate, or you can derive the public key from the private key. But if you don't have private key, you cannot derive the public key from the private key. what the private key can be derived from the public key can be derived from the private key, and it is much more secure because whoever is whoever basically creating or whoever is encrypting the data, they will have the private key, so they will easily decrypt the message. They will not share the private key to with another person or another member, so it is more secure. So there are few algorithms which basically used by the public key cryptography. So one is ECC, next we have a Diffie-Hellman, next we have a DSA, and then we have a RSA, and last we have a ECDH. There are many more also. I have chosen few names here. So basically these are the techniques which we used, cryptography techniques which we use to secure or encrypt or decrypt our data. So thank you so much. See you in next video. I hope this cryptography part is clear. Thank you so much. See you in next video.